On behalf of the University of Alberta Information Services and Technology Research Computing Group, WestGrid, and Compute Canada, I'd like to welcome you all to our first session of the Fall Bootcamp for Research Computing. I'm Scott Dellinger, Director of Research Computing. Other people from the Research Computing Group here are Chris Wundt, Camille Marcinkowski, and Dr. Irming Pei, who will give us our first session of the 2-week period on Intro to Cloud Computing. Irming.
Thanks, Scott. Yeah, thanks everybody for attending my cloud sessions. Yeah, today I'm going to introduce about cloud computing. Just briefly introduce myself. My name is Irming Pei. I'm from the Research Computing Group, led by Scott Dellinger. Me and my other co-workers, Camille, Chris, and John, we are based at UA, but also work for Compute Canada. For example, I work for the Cloud National Team and some other national teams. And Camille is leading the scheduling team, and Chris is in different national teams. Okay, let's move forward. Before I dive into the cloud computing details, I would like to introduce a little bit about the evolution of advanced research computing. As we know that at the very beginning, the so-called high performance computing were based on the so-called mainframe computer systems. They feature high performance, high capability, capacity, centralized resources, but they were relatively very expensive and not so flexible. Later, when personal computers are invented, researchers sought to use some cheaper solutions, just put the personal computers together to do batch jobs, and at the same time to divide their jobs and data into small pieces so they can do the jobs in parallel. It's cheaper and more flexible. And later, the so-called distributed computing technology emerged. So we found that we can put all the geographically computer resources together to do more computation job. Even we can do it globally, like the so-called grid computing. So we combine multiple clusters together, do global scheduling, and also can organize people or users in different into different virtual organizations according to their areas, projects, yeah, and give them different privileges. And it also features transparent data access, so users can transfer data across different sites from different places transparently using kind of a unified protocol. All of the stuff were based on the unified security infrastructure. So, and now we are in the so-called cloud computing era. So the pendulum just swings back to the central again. Cloud features virtualize everything and turns everything into service. Also based on the cloud computing technology, and there are a huge amount of data produced each year. So it's the so-called big data technology that features big volume, big variety, and big velocity. Based on that, we are now developing so-called artificial intelligence computing technology that aims to make computers think and act like human and rationally, yeah. Okay, as I mentioned that cloud, the target is to make everything as a service. This slide shows how much effort you need to do in different level of service. Traditionally, the on-premise system, you need to do everything from network, storage, server, operating system, middleware, data, until the applications. With IaaS, the second pillar, you can see that we users only need to worry about operating system, data, applications. So you don't have to purchase the hardware. You don't need to do networking, storage, servers, or even virtualization. With a platform as a service, you can even do less. You only need to put your data there in the cloud and deploy your applications. So you don't have to worry about even the operating system or even some middleware. With the so-called software as a service, it nearly has done everything for you. You only need to focus on your own business. So moving forward, we are going to make everything into service, or turn everything into service. So even like some other stuff like security, like some other like a database. Yeah, so even AI, machine learning, all the software, all the kind of protocols, policies, we can make all of them into service. So researchers only need to focus on their own core business. Yeah, but this is an idea. We still have some distance to go. Yeah. Okay, this slide shows that cloud computing is covering more and more needs, including those conventional long tail needs, like what we could do on desktop or laptop. For example, Gmail is a very good one. Nowadays, we don't have to install any client, anything, but just open Gmail from a browser, then we can just use it to send or receive emails, as well as some office tools like the G Suite. Like we don't need to install Office Word or PowerPoint. We just open those tools in a browser, then just use them. So they are all based on a cloud. More than that, cloud also covers some other even high performance computing needs with more computing intensity. So yeah, cloud is doing more and more. Next, I'm going to introduce the the Compute Canada cloud systems. By the way, Compute Canada is a consortium that covers 4 regional consortia. They are Westgrid, Compute Ontario, and Quebec, and ACNet. In each region, there is a bigger system, and most of them have a cloud in their region, like Abutus, Cedar Cloud, it's in BC, and Gram, it's in Ontario, and Beluga Cloud or East Cloud, it's in Quebec. So Abutus, just a little bit more details about each cloud. Abutus is the biggest one in Canada. It's located at University of Victoria. It's a pure cloud system with a big amount of computer resources and storage resources. And the Cedar Cloud is located at Simon Fraser University. It's a smaller. It's also run by the Abutus team. We have East Cloud, but it's going to be decommissioned. It's at University of Sherbrooke. Gram Cloud is at University of Waterloo. There could be a new cloud soon. It's called a Beluga Cloud. They are all running the open source software called Openstack. It's a middleware to run computer and all other auxiliary services, and also use Ceph as the storage management system. Here we can see the results, how many CPU cores and the storage with Abutus. By the way, Abutus is named after a kind of trees at BC. See, from the picture, we can see this is the largest Abutus tree in BC. This is the URL of for users to access the Abutus cloud service. It has roughly 15,000 CPU cores on top of 456 nodes, 5.7 petabyte Ceph managed storage, and 146 terabyte RAM. And moreover, we are deploying about 100-ish virtuous GPUs. That means we can run or use the GPUs with the cloud and split them into small pieces for individual users to use. It has more flexibility than the traditional GPU on cloud. We are also deploying object storage and Ceph-FS. Object storage has more advantages over the traditional ones, and has more scalability and more redundancy. Ceph-FS is a kind of a shared file system for cloud VMs. Those new technologies are all on pilot stage, so only open to limited users for now. but I think soon it could be open to public. Cedar Cloud, it's also named after a cedar tree at BC. It has 960 CPU cores, 500 terabyte self-persistent storage, and 7.5 terabyte RAM. Gram Cloud, it has 760 CPU cores and 84 terabytes self-storage and 5.5 terabyte of RAM in total. So it's named after the first director of their computing center at Waterloo, West Graham. East Cloud, it's still running, but it's going to be decommissioned. So it's at University of Sherbrooke. It has 476 computer cores and 100 terabyte self-storage and 4.5 terabyte RAM. As I said, the Beluga Cloud will be coming soon. It's located at ETS in Quebec. It has roughly just a little bit more than the Gram. Yeah. They have more SSDs, just more better storage, quicker, and even better interconnect, better network performance. Yeah. We'll see. Yeah. Once it's commissioned, we can update you guys about the details. Next, I'm going to talk about allocation of cloud. For people who has only have limited computing needs, there is a rapid access service for them. They don't need to apply for formally apply for rack allocation. Sorry, rack stands for resource allocation competition. So each year in fall, basically at the end of September, there is a rack request or application. So users have to apply for resources formally. But for cloud users, if you just need some resources rapidly, you can use RAS. There are two categories: compute cloud or persistent cloud services or resources. I will introduce this in next few slides. Just let you know that if your computing is only up to 80 vCPUs or 25 vCPUs for persistent, and the storage is less than 10 terabyte, you can just use the RAS service. Later, I'll tell you how to apply for it. And the RAS, you can apply it for it at any time in the year. If you need more than RAS, you have to go through the so-called RPP application. That, as I said, in EG4 at the end of September. So basically, if the resource is more than 80 vCPUs, or persistent resource more than 25 vCPUs, or storage more than 10 terabyte, you have to apply it formally. So as I said, there are two categories: compute and persistent. What are these concepts? Compute means instance or hypervisors are with high performance processors, but with a limited lifetime. It's mostly for computer intensive or CPU intensive needs. It's also referred as batch instances. Persistent. It means some services are to be run permanently, like a web service, database. In general, on those physical hosts, there are more instances run than the physical cores. We call it over subscription. Yeah, normally the ratio is up to 10:1 for persistent resources, while compute is 1:1. So for the CPU intensive purpose, computing purpose. So because web service or database, they need not so much CPU resources. Okay, how to access the cloud? Before you access a cloud or apply for cloud resources, you have to apply for a Canada account if you don't have one. So this link guides you how to do it. Once you get a cloud Canada cloud account, sorry, just Canada account, then you can sign up to a cloud by clicking on this link. After that, you can request for RAS at any time in the year. This link at the bottom, you can see there is a RAS request form that guides you how to just tell the system and how many CPU resources, how big the storage and the RAM you need, and some other resources like floating IP, snapshots. Yeah. In the end, once it's approved, a project will be set up for you with some quotas. Like I said, how many vCPUs, RAM, storage, volumes, snapshot, IPs. Yeah. If you need more, and the numbers are still less than what the limited, they are limited on RAS, you can just email to us, then we can just grant them to you. Next, I will show you how to send emails to us or how to get the support. Oh, by the way, to use the cloud, you just, once you get your account and get the project set up, you can just access them via your, with using your Canada user account and password. So we can see that here, those are the entry point of each cloud, Abitus, Cedar, East, and Gram. Some people may want to ask that why they are separated, why they can we cannot have one entry point. We were working on this, but it takes time to implement that, and at the same time, different cloud systems and team, they want to run their own systems. So yeah, this is a kind of a project that takes time to coordinate. So this slide shows how to get the cloud support. For users, you just simply send an email to cloud@campuscanada.ca. That's what all you need to do. Once we received this your email, there's a system called OTRS. It will automatically generate a ticket, and internally our national cloud team will see it, and then we'll triage it to a certain cloud team. So by the way, in the email to cloud@campuscanada.ca, you'd better note that which cloud you are using and what's the problem. Better show the error message you get, or state clearly the issues you have, because often we saw some users just say, okay, I got a problem with my VM. We get no more details, like which cloud and what kind of issues, or which VM. You may have to tell us what's the name of the VM or your project, or the ID. Yeah. So just get us support you quickly if you get more details first. Yeah, after the ticket is sent to a cloud team, they will resolve it or communicate with the user, and then it is resolved for you. And if you still have any more questions, you can keep updating or just by replying this email, the email sent to you. Yeah. Okay. Next, I'm going to talk a little bit about commercial cloud and or public cloud and some private cloud made by Openstack. So for the public cloud, the well-known ones are Amazon Web Service or AWS, Google Cloud Platform or GCP, Microsoft Azure, and IBM Bluemix. Yeah, they provide very comprehensive services. Yeah, but they also very costly compared to Canada resources. Well, Canada resources is based on OpenStack. It's open source, and it has no charge on researchers. You just access it, you get your allocation. Yeah. Yeah. So this slide shows the components inside OpenStack. For example, compute or Nova. Nova is for compute, and Cinder is for block storage. Neutron for networking. Glance for image services. Just like what kind of image you want to run for your VM. You choose the OS flavors like Linux or Windows, Ubuntu or CentOS. Swift for object storage, and on top of that, it's the dashboard or graphical interface or web on web browser for users or for system admins to access and manage the resource. All the components are based on the Keystone services for identity, for IAM, identity authentication management. I mentioned the block storage and object storage. Nowadays, in most of the cloud, we just use Ceph to replace them or to connect them and use a Ceph to manage the backend storage separately, because Ceph is a very robust, comprehensive, strong, powerful storage management system. It supports not only block storage, but also object storage. Also, Ceph-FS, the shared file system for VMs. Yeah. Okay. Yeah. In the next seasons, on Wednesday and Friday, I will be introducing about OpenStack and potentially cloud commercial cloud operations, like how to launch a VM and run it operated on OpenStack or on, let's say, for example, on AWS. And I will also guide you guys to try to use some advanced computing technology to use the cloud. For example, to use Heat-based stack service to run the cloud service, like to launch a VM in a batch way, in a orchestrated way, and to run some other services just by manual coding, so you don't have to do it repeatedly on the graphical interface step by step. Yeah, just run a code. Yeah. So we still have some spare spots. If anybody who hasn't yet registered want to join, you're still welcome to join. Yeah. So I think that's it. Next, I'll open for questions or even comments. You can unmute yourself to just ask questions or make comments.
Hi, Armin. Thank you for your presentation. That's quite informative.
Thank you.
Yeah, since I'm quite a freshman in cloud computing area, so yeah, I just learned lots of new terms, new words, and new terminologies. So I just have a maybe quite silly question. So what's the difference between the virtual GPU and GPU?
Oh, that's a good one. GPU, physically they are the same. Just on cloud, we can use it. We can just access it. Traditionally, just use a PCI pass through. We see the whole card as one piece of GPU resource. But for virtual GPU, we can virtualize it just in a VM on top of the GPU or the OpenStack or other cloud services. We see the card or the resources which, on the GPU, physical resource, just into different separate pieces, smaller pieces. So we can divide it into different pieces for different individual users, just more fine control on the GPU resource.
Okay,
Yeah.
that's clear now. So just a follow-up question. So the capacities of one piece of virtual GPU is completely the same as the physical one piece of GPU. Is that correct?
Just
Based
one
on the
piece
capacity
versus
function.
multiple pieces. Yes, you can understand simply this way, and more control on them. If it's just one piece and the PCI pass through, we administrators we have a little ability to manage them.
Yeah.
But for users, for different users, for scheduling jobs, we have to wait till one user's job is down and then schedule another one. But for multiple pieces, we can do much more, right?
Yeah, I see. So for the virtual GPUs, I have control for more pieces of GPUs. Is that correct? I mean,
Right.
there are more available GPUs
Yeah.
for me, and
Yeah.
okay.
And the more jobs can run on different GPUs. Right? Yeah.
I see. And just one more question about the
Sure. Yeah.
ratio about the compute storage and the persistent storage. So you said for the compute is 10:1, if your memory is correct. Yeah, I'm sorry. So for the persistent is 10:1, and for compute is 1:1. So for the 10:1 ratio, does it mean if I have 100 instances, I will need 1,000? I have to allocate 1,000 storage or something. I don't know the.
No, indeed, this is just a kind of a perspective from the system admin end, because we just to avoid the waste of resources for the persistent services, because they use very little CPU time. We just it's also kind of a virtualization, or just split the CPU to different time fragment. So one CPU core can run different services at the same time. You can say it's at the same time, but indeed it's a cycle scavenging. So just multiple services are run on one CPU core in parallel. So in this way, we can split them into, let's say, 5 or 10, just up to our settings. So, but for users, it's you don't see the difference, right? As long as your service is running well, you don't see the difference.
Yeah.
Yes, Ermig, if I may?
Yeah, for sure.
Okay, so basically when you're running a service like a web server, most of the time it's sitting not being used. So that's why we can over provision a cloud, because there's many web servers, but only 1 or 2 of them may be used at any one time. So we could give a core to each of them, but we would give more cores than their actual real cores. Because not every web server will be used at the same time, for instance.
Yeah.
Just for additional context, when Camille says it's not being used, basically it's just sitting around waiting for someone to hit the URL and then service the request and feed up the pages. So all it does is wait most of the time. So that's why you can do this over provision.
Okay, so the ratio means one core can be used by 10 services?
10 processors. Yeah.
10 processors. Oh, I see. I thought if I want to create one, I have to create 10. Okay.
Oh, nothing to do with the users. Indeed. You don't have to do anything different. Yeah.
Okay.
First, we can give one CPU core to multiple users. Yeah.
Okay.
But for compute, it's we want give just use them more efficiently. So maybe one is not enough for one process. We have to give a more for just one multiple cores for one job. Yeah.
Okay. Yeah. Yeah. I see. Yeah.
Okay.
Yeah. It makes sense since yeah. I see. It's like you. Yeah. I see. I know. Okay. Yeah. So I don't have any more questions. Thank you, Erwin, and thank you, Carmel, Chris. Thank you very much.
Any other questions from other audience?
Hey there, I do. It's just a logistics question.
Okay.
I'm a grad student and I was just looking to get an account on Compute Canada, but I'm pretty sure my PI does not have an account because it's a microbiology lab and I'm just checking out the idea of using cloud computing for some of our larger projects. Is there a way for me to get access for the hands-on class without having to have her go through the process of getting an account?
Oh, for the hands-on one, oh yes, we have some guest accounts for you, so you don't have to go through your PIs.
Great.
Yeah.
Okay, thanks.
Yeah.
Also, if you're going to take the other non-cloud courses, those ones are available without what's it called, a Compute Canada account as well.
Yeah, before the next session, I will send out so-called Etherpad. So, and with a bunch of guest accounts for you guys to choose which one you want. Then you just put your name to it. So, for example, if I want to select guest 150, I just put my name to it. So, yeah, that's just a temporary setup for this workshop. Any other questions, comments? Okay, if not, I think we can wrap up earlier. Again, if you are still interested into the hands-on session and the advanced session, you're welcome to join. We have, I think we still have the capacity up to, I think 50 users, guest users can access the resource. So we still have, I think, 8 to 10 slots. So yeah, feel free to join. If it's run out, so we can still find some other ways, maybe. Yeah. Okay, thanks for joining. Any questions? You can, I don't know if you guys have my email. Maybe I just put in my email or send to the so-called researcher.support@yourboda.ca. Just reply my email I sent to you for any questions, concerns. Otherwise, we will meet most of you guys on Wednesday and Friday. Okay.
Thank you.
Thank you. Have a good day.
Yes.
Bye-bye.
Also, there is other sessions happening on Tuesday and Wednesday. So on tomorrow, the Python sessions are starting in the morning on Tuesday and Thursday. And then the following Tuesday and Thursday, there are 4 Python sessions. While in the afternoon, on Tuesday and Thursday, we're starting with HPC Shell, which is using a Unix computer for high performance computing. Then the HPC Essentials on Thursday, followed by parallel computing on the following Tuesday, and HPC tuning on the Thursday. In addition to that, on the 7th, there will be social media APIs, which John will do, and regular expressions in the afternoon. In addition to that, there'll be a RAC resource allocation competition talk on Monday.
Okay, good.
Everything Camille just said has been dropped in the chat for anybody that would like it. There's a link there.
Okay, nice. Thanks everybody again. Have a nice day.